Fractional exponents allow us to rewrite a radical in a different form that may help us to simplify the radical. The statement that shows this relationship between radicals and fractional exponents is given here. The nth root of a can be written as a to the 1 over nth power. Notice the n on the radical is the index of the radical. It's written in the denominator of the exponent. So for example, 25 to the 1/2 power is the same as the square root of 25. Notice the denominator of 2 and the exponent as the index on the radical. Square root of 25 would be 5. Or 27 to the 1/3 power is the cube root of 27. Notice again, the denominator on the exponent is the same as the index on the radical. Cube root of 27 is 3. Let's throw a negative in here. Let's say we have negative 8 to the 1/3 power. Notice I do not have parentheses around the negative 8, which means that the 8 is the only value being raised to the 1/3 power. In other words, if I write this as a radical, I would have a negative of the cube root of 8, or the negative of 2. If I would have written it like this, the cube root, or the 8 to the negative 8 raised to the 1/3 power, now negative 8 is inside the radical. Cube root of negative 8, it would also give us a value of 2, but it's just coming about it a different way. And what if we have a negative fractional exponent? Thinking back to the negative exponent rule, we could rewrite this as 1 over 125 to the positive 1/3 power. We could then rewrite that denominator as the cube root of 125, or the denominator could be written as 5. So the final value is 1/5. Let me give you some practice problems. The first one, 64 to the 1/3 power. Pause the video, work the problem, and come back when you want to check your answer. In this case, we have the cube root of 64, which is 4. Another example, negative 27 to the negative 1/3 power. Pause the video and come back when you want to check your answer. In this problem, negative 27 is in the radical. Actually, before I do that, let me use the negative exponent rule to rewrite this as 1 over negative 27 to the positive 1/3 power, so I got rid of the negative exponent first. And then I can rewrite this as the cube root of negative 27. The cube root of negative 27 is negative 3, and so my final value is negative 1/3. And one more example, or one more practice problem, negative of 81 to the 1/4. Pause the video and come back when you want to check your answer. In this problem, the negative is not in parentheses with the 81, so we only have negative of the 4th root of 81. The negative is on the outside. Or the negative of the 4th root of 81 being 3, negative 3. Let's look at a few other examples. Let's look at some exponents that are not written as 1 over some value. For example, 27 to the 4/3 power. 27 to the 4/3 can be rewritten as 27 to the 4th raised to the 1/3, or 27 to the 1/3 all raised to the 4th power. I can simplify either one of these, but if I work this problem from the inside out, 27 to the 4th power will give me a very large number. I might want to avoid doing that, because then I'd have to take the cube root of a very large number. But if I rewrite this as 27 to the 1/3 power, or the cube root of 27, That, inside the parentheses, will give me a small value that I can then raise to the fourth power. 3 to the fourth power is 81. Or, let's look at this example. 32 to the negative 2/5. Let's get rid of the negative exponent. So 1 over 32 to the positive 2/5. That can be rewritten as 32 to the 1/5 all squared. I could have also written as 32 squared all raised to the 1/5 power, but again that would give me a large number to work with, and I'm trying to do these mentally. 32 to the 1/5 is the fifth root of 32. Fifth root of 32 is 2. 2 squared is 4. So I have 1/4 as a final value of 32 to the negative 2/5 power. For a practice problem, try this. 81 to the 3/4. Pause the video and come back when you want to check your answer. We can write this as 81 to the 1/4 power all cubed, or the fourth root of 81, quantity cubed. Fourth root of 81 is 3, so we have 3 cubed, which is 27. And another practice problem, 9 to the negative 3/2. Work this problem and come back when you want to see the answer. In this case, again, let's get rid of the negative exponent. 1 over 9 to the positive 3/2. I can rewrite the denominator as 9 to the 1/2 power raised to the third power, or the square root of 9 raised to the third power, or 1 over 3 to the third power, which is 1 over 27. We can also work problems similar to this using variables. For example, the 9th root of x cubed. Here I have it in radical form, but it may help in this case to rewrite this in fractional exponent form. X cubed raised to the 1/9. Raising a power to a power, I multiply the exponents, x to the 3/9, or x to the 1/3. Rewriting back in radical form, that would be the cube root of x. Try this for a practice problem. The 12th root of x to the 4th. In this problem, we can rewrite this as x to the 4th raised to the 1/12. Raising a power to a power, I multiply the exponents to get 4/12. If I reduce that fraction down to 1/3, I can then rewrite back in radical form the answer as the cube root of x. Let's mix in some other rules of exponents with these fractional exponents. For example, 4x to the 1/2 times 8x to the 1/3. Now quantity 8x to the 1/3. In simplifying this, let me get rid of some of the parentheses. The 4x to the 1/2 I'll leave alone. But the 8x quantity to the 1/3 would be 8 to the 1/3, x to the 1/3. If I simplify a little further, 4x to the 1/2 times the cube root of 8 is 2, x to the 1/3. I'm multiplying, so I can multiply these coefficients, 4 times 2 to get 8, but I need to add the exponents. And to do that, I need the same denominator. So let's change these exponents to have a denominator of 6. Both exponents have a denominator of 6. Now I can add them. I can multiply the coefficients. 4 times 2 to get 8. X to the 5/6. Another example. 20x to the 4th over 5, x to the 3/2. Once again, I need to combine these exponents. I'm dividing, so I'll subtract the exponents, but I need the same denominator to do that. So let me leave the 20 and the 5 alone, but let's change the exponents to have the same denominator, in this case a denominator of 2, so 8/2. Leave the other one alone. I can divide the coefficients to give me 4. I can subtract the exponents. 8 minus 3 is 5, so I have 5/2 power on the x. So 4x to the 5/2 power. Here's a practice problem for you. (32x to the 5/3 over 16x to the 3/4). Pause the video and come back to check your answer. In this problem, once again, we have division. We want to subtract the exponents, but we can't do that until we get the same denominator. So let's write both fractions to have the same denominator. I'll use a denominator of 12, so in the first fraction, in the numerator, I'll multiply both of those values by 4 to give me an exponent of 20 over 12. In the denominator, I wanted denominator 12 in the exponent, so I'll multiply the top and bottom of this fraction by 3. I have 9/12. I can divide my coefficients to have 2 out front. X raised to the power of 20 minus 9 is 11. So the original fraction reduces down to 2x to the 11/12 power. And one more example. A little more challenging. 6x to the 1/2 power, y to the 1/3 power, quantity raised to the 2nd power, over 4x to the 1/3 power, y to the 2/3 power, quantity cubed. Pause the video and come back to check your answer. In this case, every value in this numerator is raised to the 2nd power, so let's raise 6 to the 2nd power. X to the 1/2 raised to the 2nd power. Multiplying exponents, I get x to the 1st. Y to the 1/3 raised to the 2nd power. Multiplying the exponents, I get y to the 2/3. In the denominator, we have 4 raised to the 3rd power. We have x to the 1/3 raised to the 3rd power. Multiplying the exponents, I get x to the 1st. And y to the 2/3 raised to the 3rd power. If I multiply 2/3 times 3, I get 2, y squared. I can divide numerator and denominator both by 4. My x's cancel out completely, but the y's I need to subtract. I need the same denominator in both of those fractions. If I leave the 2/3 alone but change the y squared into thirds, which would be 6/3, I can then subtract the exponents. I can subtract 2/3 minus 6/3 to get a negative exponent in the numerator, or I could subtract 6/3 minus 2/3 to get 4/3 as a positive value in the denominator. I have 9 over 16 times y to the 4/3 power. We can use this new information of fractional exponents with our laws of exponents. We can use it to simplify radicals that sometimes are a little bit more difficult to simplify when they're in radical form, but there is a direct connection between fractional exponents and radicals.